In this video, I introduce interpretable reinforcement learning for autonomous driving. End-to-end autonomous driving model is a black box that directly converts the sensor input to vehicle control. Interpret the end-to-end autonomous driving model based on deep maximum entropy reinforcement learning allows us to see the learning procedure. In reinforcement learning, our agent observes a state Z, takes the action A and policy pi, and receives a reward R. Maximum entropy reinforcement learning is used to find a policy with a maximum entropy by maximizing the expected cumulative reward. Here, this is the entropy regularization that forces the learned policy with a maximum entropy. A random variable O is used to indicate whether agent action is optimal. And the optimal policy pi makes the conditional probability P maximum because the optimal policy pi corresponding to the maximum cumulative reward R here. Besides selecting a policy with a maximum entropy, we like to see what end-to-end model learns from its environment and what guides the model to drive correctly. To this end, log likelihood of input X, mask M, and optimality variable O is defined as an objective function here. And this P is a joint conditional probability of this X, M, and O for given action A. Here is an end-to-end model. First part is a perception module. Second part is a control module. What we need to do when the module find the optimal policy, we need to know what the model learned features from the input image and what find the most important features that importantly affect the driving behavior. Because this X and M are generated from this latent state. That means we generated this input image and this mask from this latent state. This mask includes the information like self-driving vehicle in red color, as a blue is the future trajectory, as a green box are surrounding vehicles. Here as a D is a training data set. To simplify objective function, we further define these parameters. And then now we can express the log likelihood in two terms. This one is the same as the maximum likelihood reinforcement learning to find the optimal policy. That means this is a policy learning model. And this part is the environment learning model, includes 4 terms. First one is for given latent state, we find this X. That means from this latent state, we find what's the features the model learns from the input image. And this second term is for given latent state, what's the mask? That means from this latent state, what's the most important factors to affect the driving behavior. As I mentioned previously, this red is a self-driving vehicle, as blue is a future trajectory, as green box is surrounding vehicles. And this one is just prior, and this is posterior. So use this model, we split the objective function into 2 terms. One we use to find the optimal policy. Another one we explain what the model learned from the input images and what learn from the image to importantly affect the driving behavior. Like this is the semantic mask. For more details, please check with this reference. Thank you.